Welcome to my algebra class. We're on chapter 9, section 4. We're still solving systems of equations, and this method is where we're going to add or subtract the two equations we have to get one variable. So in this first example here, how do I know whether I should add or subtract? Well, we want one variable to disappear. And if I look carefully, I can see that there's a minus y and a positive y here. So if I add them, the y will go away. So I have 3x plus y equals 4. And I'm just going to set up an addition problem. I add these together, I get 8x. The negative y and the positive y disappear, make 0, and we get 8. And then we solve for x, divide by 8, and we get x equals 1. And then we can plug it back into this equation. 3 times 1 plus y equals 4. 3 plus y equals 4. Subtract 3 from both sides, and we find out that y equals 1. So the ordered pair that is the solution to this, remember they're in alphabetical order, is 1, 1. So 1, 1 would solve both problems. The second example shows where we would need subtraction, because if I look at the coefficients, it's a positive 6 and a positive 6, a positive 7 and a negative 2. Well, if I would subtract these two equations, take 6c minus 6c, then I would eliminate the c. So I'm going to put 6c minus 2d equals 12 underneath this one, and I need to subtract, so I'm going to change the signs, minus, plus, minus. You have to change all the signs. So subtracting this equation from this, that goes out. We get 9d equals negative 27. Divide by 9, and we get d equals negative 3. And we're going to substitute that back into this equation to find out what c is. 6c minus 2 times d, which is negative 3, equals 12. Negative 2 times negative 3 is plus 6 equals 12. Subtract 6 from both sides. We get 6c equals 6, divide by 6, and c is 1. So the ordered pair that solves both equations, the system, is the ordered pair that has the values for c and d, alphabetical order. So it's 1, negative 3. That concludes the explanation of the section. You need to get your paper headed and then skip a line, put 427 written 1 to 27, fold the paper in half, and open your book to that page. And the directions say to solve by addition or subtraction. So problem number 2, we have a plus b equals 5 and a minus b equals 7. Since the signs of b and the b's are opposite, we're going to add them together, which will eliminate the b, so 2a equals 12. Divide by 2, and we get a equals 6. Substituting 6 back into either one of these equations, I'll just pick the first one, 6 plus 5, 6 plus b equals 5. Subtract 6, and we get b equals negative 1. Alphabetical order, our ordered pair is AB, so it'd be 6, negative 1 is our solution. Problem number 4, we have 3c plus 5d equals 17, and 3c plus 8d equals 5. Well, I want to work with the 3's, and since they're the same sign, I'm going to subtract the second equation from the first, so I change all of its signs. So this becomes 0, and I get negative 3d equals 12. Divide by negative 3, and d equals negative 4. Substituting back into either one of these equations, I'm just going to pick the first one. I have 3c plus 5 times negative 4 equals 17. 3c minus 20 equals 17. add 20 to both sides. I get 3c equals 37. Divide by 3, and c equals 37 thirds. So the ordered pair is C, D. So 37 thirds and -4 is my solution. When you put it back in the ordered pair, you can go ahead and put the fraction all in one line. Problem number 6, 3a minus 5b equals 31. 7a minus 5b equals 59 is our system. Finally, numbers that have the same sign or same number of coefficients or opposite coefficients, it's 5, the one for b. Since they're the same sign, we're going to subtract, change the signs. So we get -4a equals 28, -28. Divide by 4, -4, and we get a equals 7. Substituting back in, 3 times 7 minus 5b equals 31. So that's 21 minus 5b equals 31. Subtract 21 from both sides. We get -5b equals 10. Divide by -5, and we get b equals 2, -2. So our ordered pair is A, B, and it's 7, -2. Problem number 8, copy the system down. 4a minus 7b equals 13, and 2a minus 7b equals 3. We're going to get rid of the b variables since they have the same number, and we're going to subtract. So change all the signs. So that gives us 2a equals 10. Divide by 2, and a is 5. Substituting that back in, we'll use the first equation. 4 times 5 minus 7b equals 13. So now we have 20 minus 7b equals 13. Subtract 20 from both sides. We get -7b equals -7. Divide by -7, and b is 1. So our ordered pair is AB, so it'd be 5, 1. Copy the system for number 10, -3x plus 5y equals 45. And 3x plus 13y equals 9. Since the signs are opposite here, we just go ahead and add. So that'll give us 18y equals 54. Divide by 18, and y equals 3. Substituting back in, you get -3x plus 5 times 3 for y equals 45. -3x plus 15 equals 45. Undo addition, subtract 15. We get -3x equals 30. Divide by -3, and we have x equals -10. So our ordered pair would be x, y. So -10, 3. And problem number 12, we have 9y plus 5z equals 1. Second equation, -9y minus 10z equals 2. Since the signs are opposite here, we just add them, and that'll go away. So we'll have -5z equals 3. Divide by -5, and we get z equals -3/5. Substituting back in, 9y plus 5 times -3/5 equals 1. So 9y, the 5's cancel, plus negative 3 or minus 3. I'm just going to change it to minus 3. Equals 1. Add 3 to both sides. So I get 9y equals 4. Divide by 9. And y is 4/9. So my ordered pair is y, z, and y is 4/9, and z is negative 3/5. On the next page, 428, the directions are say to solve by addition or subtraction method again. So problem number 14, we have negative 28g plus 15h equals negative 18, and negative 28g minus 40h equals negative 29. Since they have the same sign, we'll change it to subtraction, so change your signs. So that gives us 55h equals 11. Divide by 55, and h equals 1/5. Substituting that back in, we get negative 28g plus 15 times 1/5 equals negative 18. Negative 28g, a fifth, 5 goes into 15, 3, equals negative 18. Subtract 3 from both sides. And we get negative 28g equals negative 21. Divide by negative 28. And g equals 7 goes in 3 and into 28, 4. So our ordered pair is GH, and G is 3/4 and H is 1/5. Problem number 16. Copy the system. I'm going to go ahead and move the variable over to, move the decimal point over 2 so we don't have any decimals. So it's going to be 7a minus 3b equals the 12, adding 2 zeros would be 1,200. And the second equation, moving the decimal over 2 places, would give me a plus 3b equals 1,200. Since the 3's are opposite, just add, and we get 8a equals 2,400. Divide by 8, and a equals 300. Substituting back in, probably the second one would be the easiest. So we get 300 plus 3b equals 1,200. Subtract 300 from both sides, and we get 3b equals 900. Divide by 3, and b equals 300. So our ordered pair is A, B, and A is 300, and B is also 300. Problem number 18. We have 3/4 x minus 1/6 y equals 12, and 5/4 x minus 1/6 y equals negative 22. Let's get rid of the fractions and rewrite this completely. I'm going to multiply this one by 12, and the same with this one. So I now have 9x minus 2y equals 144. And this would be 15x minus 2y equals 22 times 12 would be 264. Since the negative 2's have the same sign, we'll subtract, change all your signs. So we get negative 6x equals 144 from 264 would be negative 120, excuse me. Divide by negative 6 and x equals 20. This was originally negative. That's my whole problem here. I copied it wrong. So equals negative 144. So adding 180 to both sides, I get negative 2y equals positive 36. And then divide by negative 2, and I get y equals negative 18. So our ordered pair is x, y, and it's negative 20, negative 18. And problem number 19 through 24, solve either by substitution or addition, subtraction, whichever one you want. The system for number 20 is x minus 5y equals 2, and 2x plus y equals 4. Well, there's no number in front of the x and the y's that are the same anywhere, so I'm going to use substitution and solve for x. So x equals 5y plus 2. Plug it in. So 2 times 5y plus 2 plus y equals 4. So I get 10y plus 4 plus y equals 4. Collecting like terms, I have 11y plus 4 equals 4. Subtract 4 from both sides, and I get 11y equals 0. Divide by 11, and y is 0. Plugging that back in here, 5 times 0 plus 2 equals 2. So my ordered pair is x, y, and it's 2, 0. And problem number 22, we have 4 times the quantity a minus 2b equals 8, and 2 times the quantity a plus 4b equals negative 8. So I multiply these out, I get 4a. Well, it actually might be even easier just to divide both sides by 4, just to get rid of coefficients. So this gives me a minus 2b equals 2. Well, dividing this by 2, I get a plus 2b equals negative 4. I would use addition here since the 2 and the negative 2 are opposites, so I could just add these two together. And these will go out, so I get 2a equals negative 2. Therefore, divide by 2, a is negative 1. Then I could substitute it in here. Negative 1 plus 2b equals negative 4. Add 1 to both sides. I get 2b equals negative 3. And I, again, have something wrong here. Let me see if I can find it. Okay, I found it here. I made a mistake right in here. When I divided by 2, it should be a plus 4b equals negative 4. So then I needed to subtract, which changes the signs. So that gives me negative 6b equals 6. Divide by negative 6, and b equals negative 1. Substituting that in here, a plus 4 times negative 1 equals negative 4. So a minus 4 equals negative 4. Add 4, and a is 0. So our ordered pair is a, b, and 0, negative 1. Problem number 24. We have 1/3 A minus 2/3 B equals 1. And then we have A plus B plus 7 equals 0. Well, in that first equation, I'm going to multiply by 3 just to get rid of the fractions. So I have A minus 2B equals 3. And here, if I move the 7 over, I get A plus B equals -7. So I could use subtraction. A plus B equals -7. So subtract, change the signs, and I get -3B equals 10. Divide by -3, and B equals -10/3. Substitute it back in here, so we get A plus -10/3 equals -7. If I want to get rid of fractions, I can multiply by 3, so 3A minus 10 equals -21. Add 10. 3A equals -11. Divide by 3. And A is a -11/3. So my ordered pair is AB. A is -11/3, and B is -10/3. And the last problem, number 26. We have 5A over 6 minus B over 3 equals 6. I'm going to multiply by 6 to get rid of the bottom, the fractions. So I get 5A minus 2B equals 36. And the second fraction is A plus 2B equals 0. So we could use addition here. And I get 6A equals 36. Divide by 6, and A equals 6. Substitute in 6 plus 2B equals 0. Subtract 6, and I get 2B equals -6. Divide by 2, and B equals -3. So our ordered pair is AB, and A is 6, and B is -3. That concludes the evens. Be sure you check the odds for the